Mangalyaan, India's first mission to Mars, left the Earth's orbit on December 1, 2013. When it reaches the Red Planet on September 24 next year, it would have covered a distance of 780 million kilometers in 10 months. But here is an intriguing question. Mangalyaan was launched from Sriharikota on November 5th and kept orbiting the Earth for 25 days before setting off for Mars. Why? After all, NASA's Maven mission, which took off 15 days after Mangalyaan, went straight to Mars. This is how it worked. On November 5th, the PSLV put Mangalyaan in a low elliptical orbit, with a minimum distance from the Earth of about 240 kilometers and a maximum distance of 24,000 kilometers. Technically, the minimum distance is called the perigee and the maximum the apogee. When the satellite is placed in orbit, it does not require additional fuel or energy. It keeps on moving, much like the Earth moves around the Sun. But at what speed does the satellite move? Well, this is determined by two things: distance from the Earth and the shape of the orbit. The closer the satellite is to Earth, the faster its speed, as the gravitational pull is higher. As far as the shape of the orbit is concerned, the more elliptical the orbit, the higher is the speed of the satellite. Now let's see how ISRO used two principles to increase the speed of the satellite. According to the first principle, when the satellite is at the perigee, its speed is at its highest. So if you give the satellite a little push when it is there, you can make it move a long distance. When the satellite is at its perigee, the mission controller in Bangalore often fire the motor on board to push the satellite into a higher, more elongated orbit, thus increasing the speed of the satellite significantly. Between November 5th and November 16th, ISRO made 5 orbit-raising maneuvers, increasing the apogee to 193,000 kilometers, which is 8 times the height at which the satellite was first placed. This pushed the speed of the satellite to nearly 11 kilometers per second, which is close to the escape velocity. So all that the mission controller needed to do on December 1st was to burn the motor one more time and push the satellite out of the Earth's sphere of gravity into the Sun's gravitational influence. Since the Earth is orbiting around the Sun at a speed of 1 lakh kilometers per hour, Mangalyaan exited the Earth's sphere of influence with the same speed, plus the additional push given by the motor. The new orbit around the Sun that Mangalyaan will follow is called the transfer orbit or the Hohmann orbit. At some point, this orbit will intersect with the orbit of Mars. The timing of the mission has been carefully planned to ensure that when Mangalyaan reaches the point of intersection, Mars itself will be there to meet it. The satellite will then fire its onboard motor, but this time in reverse direction to slow down its speed, so that Mars can take Mangalyaan into its own gravitational sphere of influence. Mangalyaan will then start orbiting Mars for about a year. So if anybody ever asks you, why is it that traveling to Mars takes only as much fuel as traveling to the Moon does, even though Mars is about 100 times more distant than the Moon, you know the answer. Most of the fuel we need is just to launch the satellite. The rest of the journey is mostly courtesy of gravity. If only we could travel with such ease down here on Earth.